So today we are going to start with a new point of the unit vectors, which is a derivative of the vectors. So derivative means in physics we know that there are many physical quantities which depends on the another physical quantity. For example, if you have the velocity, so velocity can be defined as dr upon dt, which is nothing but displacement upon time. This means that the velocity is nothing but the derivative of the displacement with respect to the time. Derivatives means dependency of a one physical quantity on another physical quantity. So in physics there are many quantities which depends on another physical quantities, and that mathematically is represented by this derivative. Okay, so for example, velocity is I will write it here. Velocity is, so as I have written here, so velocity is a derivative. So as I have written over here, velocity is a derivative of a position vector with respect to time. Similarly, we can also write acceleration as a derivative of velocity with respect to time. Now let us prove these mathematical expressions. Now let us have a Cartesian coordinate system with x, y and z directions. Let I, j and k be the unit vectors along x, y and z directions. Now suppose if I have point P and represented by the position vector small r, then position vector of this point P can be given as vector r is equal to r1i plus r2j plus r3k, where r1, r2, r3 are the magnitudes along x, y and z directions, and I, j and k are the conventional unit vectors along x, y and z directions. Now suppose this point P is moving with some velocity v, and after time t it reaches to some point P dash. Now suppose this is the point P dash, and if there is another position vector r dash which represents the position of the P dash, then this r dash can be given by r1 dash j plus r2 dash j plus r3 dash k. Now let this r1 dash represents the position vector of this point P dash, and that can be represented by r1 dash I plus r2 dash j plus r3 dash k, where r1 dash, r2 dash and r3 dash are the magnitudes along the x, y and z directions. Now if I try to complete this triangle, now if I use the law of triangle for the vector addition, then I can get, so let me call this as a capital R. So by using the law of triangle of a vector addition, so this R plus this capital R is equal to R dash, all these are vectors, or this capital R is equal to R1 dash minus R. We know the values of R1 dash and R, so let us put these values into this. So R1 dash I plus R2 dash j plus R3 dash k. So this is the position vector R dash minus, so value of this R is R1I plus R2j plus R3k. Don't forget to write the cap on this I, j and k, and also don't forget to write the vector sign on this all position vectors. Now let us take this I, j and k common. So if I take I common from this, so I am going to get r1 dash, I have forgotten dash over here, r1 dash. So here also we have to write dash, because this r1 and this r1 is not same. This is r1 dash and this is r1. So these two magnitudes are different. So r1 dash minus r1 into I plus r2 dash minus r2 into j plus r3 dash minus r3 into k. Now let us call this term r1 dash minus r as delta r1, r2 dash minus r2 is equal to delta r2, and r3 dash minus r3 is equal to delta r3. Okay, now if I put these values, so capital R is equal to delta r1I plus delta r2j plus delta r3k. So this will be the expression for this resultant position vector capital R. Now if I take derivative of this resultant position vector with respect to time, I am going to get the velocity. So I can write the expression for velocity as v is equal to limit delta t tends to 0. So d by dt of this capital position vector r. Now let me put the value of this r. So limit delta t tends to 0, d by dt of, so delta r1 I plus delta r2j plus delta r3k. So this is the value of this capital R. Now let me put this limit delta t to all this term. So I will write limit delta t tends to 0, d by dt of delta r1I plus limit delta t tends to 0, d by dt of delta r2j and plus limit delta t tends to 0, d by dt of delta r3k. So this first term is nothing but the derivative of the position vector with respect to time along the x-axis. This is the derivative of the position vector with respect to time along the y-axis, and this is the derivative of the position vector with respect to time along the z-axis, and the derivative of the position vector with respect to time is nothing but the velocity. So I can write here v is equal to vxi plus vyj plus vzk, which means that the total velocity of any particle in a Cartesian coordinate system can be given by velocity along x-axis, velocity along y-axis, and velocity along the z-axis.